Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello teacher, hello students. Welcome to today's lesson on special quadrilaterals. In the last lesson, we studied different types of special quadrilaterals. The rhombus, the trapezium, the isosceles trapezium, the parallelogram, and the irregular quadrilateral. We learned how to identify the different types of quadrilaterals by their properties. In this lesson, we will continue to learn the theorems we need to identify and construct quadrilaterals. If you are ready, we will begin. This quadrilateral is divided into 4 parts. AC and BD are perpendicular bisectors of each other. Knowing this, let us see if we can prove that it is a square. We will label the point of intersection O in order to help us. Since we know that AC and BD are bisectors, we know that AO, BO, CO, and DO are all congruent. It follows that angles AOB, BOC, COD, and DOA are all congruent as well. Because of the side angle side rule, we can see that the 4 triangles that make up the quadrilateral must be congruent. If the triangles are congruent, the alternate interior angles are congruent. Therefore, it must be a parallelogram. But we can go a bit further than that. We can also see that all of the diagonals are congruent. That condition only fits the definition of a square. Not only does the shape look like a square, we have learned how to prove that it is a square geometrically. Remember, students, that while all squares are parallelograms, not all parallelograms are squares. We have managed to discover another theorem, students. If the diagonals of a quadrilateral are congruent and are perpendicular bisectors of each other, then the quadrilateral is a square. Please make a note of this important discovery. You will find it useful to remember when identifying different types of quadrilaterals. Now we have learned all the theorems that we may need to solve any quadrilateral problem. Let us try one together. If the midpoints of the sides of a parallelogram are the vertices of a quadrilateral, what kind of a quadrilateral is it? If we call the parallelogram A, B, D, C, then E, F, G, and H are the midpoints of the four sides. Let us look at the two triangles C, G, F and A, E, H. Angle A is congruent to angle C. Line segment AE is congruent to line segment CG, and line segment AH must be congruent to line segment CF. We therefore have to conclude that triangles CGF and AEH are congruent. If we use the side angle side rule, we deduce that line segment GF and line segment EH are congruent to each other. The same set of steps used on the triangles DGH and BEF to prove that line segments HG and EF are congruent. Therefore, opposite sides of GH, EF are congruent. It must be a parallelogram. You see, students, that we can prove the nature of a quadrilateral if we remember to apply the correct theorems. Now, you shall try to solve a problem in groups, students. I will give you the necessary information to define a certain quadrilateral. You must use what you have learned to prove that the shape is in fact a parallelogram. Please start as quickly as you can. Good luck!
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Let us see how you solve this problem. We know that line segment DF and line segment BE are congruent. We can also conclude that line segments AF and CE are parallel because their counterparts AD and CB are parallel. Line segments AB must be congruent to line segment CD as we are dealing with a parallelogram. The corner angles are congruent because their constituent lines are parallel. But angle A is congruent to angle C. Therefore, the two triangles are congruent in dimension and their complementary angles match. Since AECF is a quadrilateral with opposite angles congruent and two opposite sides parallel and congruent, the shape must logically be a parallelogram. You see how to make a geometric proof? We need lots of practice to become skilled. There is time for one more activity, students. Please get ready to answer this question. The midpoints of the sides of a rectangle are the vertices of a quadrilateral. What kind of quadrilateral is it? I am looking forward to your answers. You may get started right away.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. If you correctly applied the quadrilateral theorems, you discovered that the shape that was described is a rhombus. You will remember that a rhombus is defined as having opposite sides being parallel and opposite angles being equal. We can also say that the diagonals of a perpendicular bisect each other. The shape that was described could therefore only be a rhombus. If that was your answer, you have shown great aptitude at plane geometry. Clearly, all of your practice is paying off, students. That is all the time we have for this lesson. Today, we have learned about geometric proofs and how to apply geometrical theorems to quadrilaterals. We have correctly identified squares, parallelograms, and rhombuses. Do not forget to practice identifying quadrilaterals on your own so that you might know each type by its description. Next time, we will learn more about circles. Until then, thank you, teacher. Thank you, students.